Here's something that might surprise you. In January, Earth is actually closer to the Sun than in July. It's called perihelion, when our planet is nearest the Sun in its orbit. So, why are we freezing in January? Simple answer: Earth is tilted by about 23.5 degrees. That tilt means in January the southern hemisphere leans toward the Sun, while the northern hemisphere leans away. The result? Summer down south, winter up north. But here's where things get interesting. It's not just that sunlight hits at an angle. It's that the angle changes everything. Sunlight doesn't hit us directly. It first has to pass through our atmosphere. And when you're tilted away, that sunlight travels through a thicker slice of atmosphere, scattering more, weakening more, before it ever reaches your skin. Think of it like this. In summer, sunlight takes a short, straight route. In winter, it takes the scenic route, dodging molecules, bouncing through clouds, and losing intensity with every kilometer. So while the actual distance from the Sun changes by just 0.004%, the effective distance, the amount of energy that reaches you, can drop by 30% to 80% depending on where you live and how low the Sun sits in the sky. When the Sun is low, its light spreads across a wider area, delivering less energy per square meter. That's why the same sun that toasts you in July barely warms your fingers in January. So yeah, Earth may be closer to the Sun in January, but that sunlight is taking the long way around, filtered, weakened, and delivered at a slant. Seasons aren't about distance, they're about tilt, angle, and atmospheric filtering. Winter is cold not because you're far from the Sun, but because the Sun's power is being spread thin and stripped down before it even gets to you. Next time you're shivering in winter, remember? It's not how close you are, it's how the sunlight has to fight to reach you.